Alright, so what do we got here? Just playing around with drain pump motors and trying to understand a little bit of how they work and how I can mess around with them to do other things. So I've taken them apart. I have got 3 of them here taken apart, and I'm playing just with their inductor coils and the steel cores. Now, there was one that I didn't use, and there was a reason. It's because if you listen to it, the note, I can't ding it there, but the note, this guy, is slightly flat when I compare it to the ring of this guy and this guy. And so even though this guy is smaller than that guy, the pitch is actually very, very, very close. It's hard to tell the difference. Sounds almost on point. So the way I have it set up here, I've got 120 volt coming in. So we got live into neutral into this small little 5 VA transformer, gives me about 13 volts RMS. And what we have here, we have the transformer coming out into this inductor here, and then I've wired it so that this inductor is in parallel but reversed, flipped. So it's not purely parallel, it's anyways. So what I found was when I don't have that flipped here and that they're both parallel, the same sides going, the voltage doesn't go up as much. I get maybe a 1 or 2 volts increase from the regular voltage, and I'm just for whatever measuring voltage over here off of this tertiary inductor. It's the smaller coil. Yeah, so they're all from different pump motors too, right? So there's no matching of impedance here. So let's see what happens when we turn it on. We get a nice little hum, and gives us about 17.334 volts. So I'll just show you again what happens when I switch these two. And I'm playing with lower voltages, just, so I'm just kind of being a little extra precautious, so I'll hit our switch again. Doesn't vibrate or hum as much, and I get only slightly above regular voltage, which is what that little transformer can do. So what seems to be happening here is some of the interfering or interfacing waves, right? Because you're getting waves coming in this guy and in that guy, but these ones seem to be I think they're out of phase, unless I completely understand this wrong. Well, there might be something to also these direction that they're situated at, right? Because it winds up this way, across, and then down that way, and then it winds up this way, across, and down that way. So they're kind of counter into each other. I'm going to try switching them around. So, switched it around. Doesn't look as pretty because it's kind of awkward with the plastic casing. It's on a bit of a slant, but kind of still get an increase. But I think you can see it's about 16 volts RMS. Now, you can hear that noise, that nice yummy yummy hum, and it seems to be that the loose alignment there and things aren't quite straight. You're going to get noise from between the 2 cores that are not exactly snug together. They've got a little bit of room, even though I tried to put a little tension with those rubber bands. It's still not really that tight. So it seems to be. I'm guessing that's why I'm getting only 16 volts instead of 17 as it was before. Now, do is we'll switch this around. Okay, and that guy on here, and this guy on here. Alright, so we're back to regular 13 Well, just slightly above 13. Hums a little bit less, but I don't think that works well. So, very interesting. Alright, well I just wanted to show you the pitches of these three. So you just get an idea. You get the first one. Nice and high. Second one. So as you can see, very, very close. Even though, you know, the sizes are distinctly different. I'm guessing it has to do with tension, right? You know, they're at about similar. Oh, what's that? What's that? It's... Brr. So he's tuned to slightly lower, so his resonant frequency is a little bit different, right? So that's why I was mainly sticking with these two until I find other parts to play with.